Boys, today we are looking at how we can convert angles measured in degrees into radians around the unit circle. So let's just have a look at our unit circle here. So here's our unit circle, and to begin with, we'll look at some of those exact values that we've got. So some nice background noise there for you. So if we go around the circle, we already said that the whole way around is 2 pi, and halfway is pi for 180 degrees. And so if we break that up now, we can see that if half of the circle, 180 degrees, is pi, then 90 degrees is pi on 2, because that's half of it. A third of it, so a third of 180 would be pi on 3, would be 60. A quarter of it, 45 degrees, would be pi on 4. And 1/6 of it, 180 divided by 6 is 30, would be pi on 6. So that's how we convert those degrees into radians. So now if we fill out this next sort of quarter from 90 to 180, 120 is going to be, what's double 60, so that's going to be 2 pi on 3. 135 is 3 times 45, so that's going to be 3 pi on 4. 150 is 5 pi on 6. And now going to the last sort of quarter, the second half and next quarter. If we add 30 degrees onto 180, we're essentially adding a pi on 6 to it. So it's pi plus pi on 6, which gives us 7 pi on 6. If we now add 45 onto pi, we get 5 pi on 4. Keep going around, 4 pi on 3. And then 1.5 pi is 270, which is 3 pi on 2. And if we continue around, 5 pi on 3, 7 pi on 4, and 11 pi on 6. So that's converting those common values into degrees into radians, those exact ratios. And so down the bottom, you've got the special angles. So 30 degrees is pi on 6, 45 is pi on 4, 60 is pi on 3, and 90 is pi on 2. And so you remember we've got our exact value triangles. So if you remember those two, 45, 1 root 2. And so of course these 45 degrees in here, that's the same as pi on 4. And so our other one, so 60 and 30, 30 of course is pi on 6, and 60 is pi on 3. So now that we can sort of convert them, you can figure out those exact ratios both in degrees for this table and also in radians down the bottom, so you can fill those ones out. So let's have a look at the questions on the next page. So you need to convert pi on 3 into degrees. So if we just look at our table from the previous page, we can see that pi on 3 is the same thing. That's 60 degrees. Now, finding the exact value of tan pi on 3. Well, that's asking us for the same as tan 60. And so tan 60, we just refer to our triangle quickly, is root 3 over 1. So root 3, so tan of pi on 3 is root 3 over 1, which is root 3. Exact value of cos pi on 4, so pi on 4 is 45, and so we'd refer to our exact value triangle with the 45 in it, and cos will be 1 over root 2, so cos of pi on 4 is 1 over root 2. So it's the same sort of process, except we're now using our radian angle measure. Okay, and so we've looked at the exact values, and so any values around the unit circle, any angle measurement in radians we can find a value for, and like working in degrees, we still apply the all stations to central. I was on all stations today, and so if we fill out this, we're looking at, well, what's it like in the second quadrant? Well, second quadrant angles are always this pi minus theta. So sine of pi minus theta equals sine theta. So these are all the same here. So in the second quadrant, sine's positive, the other two are negative. Third quadrant is pi plus theta, just like it would be 180 plus theta. And of course, tan is the one that is positive in the third quadrant. So negative sine theta, negative cos theta, positive tan theta. Fourth quadrant, cos is positive, the other two are negative, and that's 2 pi minus theta. 2 pi is the whole way around. Take off theta in the last quadrant. So we get minus sine theta, cos theta, minus tan theta. These are for positive angles, and like we did for degrees, we can also look at it in terms of negative angles. So negative angles now, fourth quadrant, negative theta, and only cos is positive there, so that'll be negative sine theta, negative tan theta, positive cos theta. In the third quadrant, it's minus pi minus theta. So it's basically minus 180 minus theta, so it lands you in the third quadrant. And in that quadrant, sine's are negative, cos is negative, tan is positive. Second quadrant is minus theta, sorry, pi plus theta. So minus pi plus theta minus pi plus theta. And so that gives us sine theta being positive in that quadrant, cos being negative, tan being negative, second quadrant. So the first quadrant is minus 2 pi minus theta. So that's all positive in the first quadrant. Hopefully you're starting to get really confident with knowing which one is positive in which quadrant. Okay, so you've got to find the exact value of sine 5 pi on 4. So sine 5 pi on 4, that is, well, it's bigger than bigger than pi, so it's bigger than, it's not going to be in the first or second quadrant, it's going to be in the third quadrant. And 5 pi on 4, if you think about exact values, that's essentially the same thing as sine pi plus pi on 4, which is third quadrant, so that means it's negative of sine theta, which is pi on 4. And being negative now, and pi on 4 is a nice exact value triangle scenario, 45, 1, 1, root 2, so it's going to be 1 on root 2, so it'll be negative 1 on root 2. Now, 11 pi on 6, 11 pi on 6 is in the fourth quadrant, and it's the same thing as 2 pi minus pi on 6. And so we're actually looking for the exact value of cos pi on 6, which is cos 30. So cos 30, exact value triangle. See how often we use these? Root 3 on 2. And it's positive in the fourth quadrant for cos. So all stations 2 central, there it is. Up here we were in that quadrant. So this is going to be root 3 on 2. And that's the content for today.